Multimodal Video Search by Examples, a Video Quality Impact Analysis by Wu et al., published in IET Computer Vision. Welcome to Journal Club. I'm Malcolm Diggs. Let's say you're a software engineer at a major video streaming company. This could be a Netflix, Max, YouTube, or even a Twitch or Kick. Either way, your company's core competency is video. Ingesting it, processing it, encoding it, and decoding it, hosting it, and streaming it out to customers. And you're good at it. But a new feature request just came down from on high, and it's, well, as we like to say, non-trivial. What feature? Search. Not just any search. You have standard search already. You store a bunch of metadata and tags about each piece of content. So when a user enters something in the search bar, you query your database or your Elasticsearch, look for matches, sort with some kind of relevance approximator, and return the results. But this feature request is different. The product team says that simple metadata search is old, and they want something new. New is letting users search for words that the characters are speaking within a video. New is letting users upload a video clip that they might have pulled off of social media and returning to them the full video where the clip came from. New is allowing users to describe a scene they once saw in a movie and returning that scene and movie to them. New is allowing users to upload a photo of an actor or an audio clip of that actor speaking and returning every piece of content and scene where the actor has appeared, even if that actor was just an extra in the background. New is doing the same, but for inanimate objects, allowing users to describe or upload a photo of a landmark, product, building, or city, and then returning to them all the scenes and all the content where that thing or place appeared. In other words, this feature request is for multimodal video search, the ability to search within video content for anything appearing or happening in that content, using whatever query medium the user prefers. This means searching with text, with audio, with photos, with video clips, figuring out relevance and returning streaming video. That's the feature. Quick little feature request, right? Something you can bang out in an afternoon, right? Right? Let's say you actually received this request. You pulled it right off the top of the backlog in a sprint planning meeting. And now the PM is staring at you like, how many story points is that? Your first instinct is going to be to throw your laptop at them and walk right out the door. I get that. But don't do that. Might I suggest that instead, you dive into this paper with me right now. This paper is an early prototype, let's call it a sketch, of what this kind of multimodal search could look like and how you could build it. The authors focus on a few questions. How do you pre-process your video content to extract the information you're going to need from each video? What do you end up storing and indexing? How do you ingest the user's queries and normalize them into a format that can be run against the data and indexes you're storing? And how does that query work? To borrow some phrasing from Hadoop, how do you take that query and get a map of intermediate results and then reduce and sort them to the final output? Spoiler alert, not with Hadoop. I wouldn't characterize this article as a system design paper, no. I think this is the step before that. This paper is more of a meditation on the architecture, the kind of high-level thought experiments you conduct with your team in front of the biggest whiteboard you can find. That's the space we're occupying here. High-level data structures, high-level algorithms, and high-level estimates of time and space complexity. The goal is to flush this out just enough that you can come back to the product team and say, here's how long it's going to take, here's how much it's going to cost, and here's how many engineers I'm going to need. All right, enough preamble. Let's get into it. In my opinion, there are two primary contributions of this paper.